Welcome back to Learning Here with us at MPB. I am Ms. Killen. We're looking at some more Algebra 1, and we are into our lesson number 11 of Chapter 5. We're finding solution set to the inequalities with two variables. We're looking at our standard CED 3 and REI 12. I can understand solution sets of inequalities are where they are shaded and for systems where the shading overlaps. So let's look at some problems. First thing I want to do is review our inequality symbols. Now, I know that we have been learning about these ever since middle school, which is fine, but I want to make sure that we understand what all four of these mean. This less than symbol, when I am graphing it, it is going to be graphed as a dotted line. And my less than or equal to symbol is going to be graphed as a solid line. These two symbols mean I am shading down. Now you want to make sure that you are putting these in your notes page because we're going to refer back to these when we're doing some more problems. So let's look at the next two. I have greater than. Again, greater than is going to be graphed as a dotted line. Greater than or equal to is going to be graphed as a solid line. And then when I graph these, what I'm doing is I am shading up. Now you're looking at these and you're saying, Ms. Killen, I've got dotted and solid. How can I be for sure which one gets dotted lines and which one can be solid lines? There is the simplest, easiest way to remember. If my symbol has a line underneath it, you have a solid line. If my symbol does not have a line underneath it, you got a dotted line. There you go. You never have to worry about it again. So let's look and see how we can use that. So it says, look at the following inequality. I have 3 is less than, I have y is less than or equal to 3x plus 2. Which of the following ordered pairs are solutions to this inequality? So I have my inequality, and then I have which one would be part of the solution. So let's graph this and see what we've got. So what I'm going to do is I'm going to have my x and y values. So here's my 0. I'm going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4. Now, Ms. Killen, how am I going to graph this? I don't have my calculator up, and you told me not to use Desmos yet, so what am I doing? The easiest way for us to graph these is start at the beginning, which is at my y-intercept. And remember my y-intercept, mx plus b, that positive 2. So I am going to graph this and start at my positive 2. So here we go. This is where I'm starting to graph. Now, how do I find those other points? I'm using my slope, which is 3. Since I just have one number, I know that I can make that as a fraction, my rise over my run, by putting a 1 under it. So I'm going to go up 3, 1, 2, 3, and over 1. 1, 2, 3, over 1. I can go down and over 1. 1, 2, 3, and over 1. 1, 2, 3, and over 1. How is my line going to look now? I have the less than symbol, but it's less than or equal to. So it is going to be a solid line, if Ms. Killen could draw a straight line. Now, which way am I going to graph? It says that my y's are smaller. So that means I am graphing or shading down from the line. So there is my graph, so to speak. Now it wants to know which of the following ordered pair is part of the solution. When we have solutions of inequalities, all those solutions are going to be where it's shaded. If it's a solution, it's in the shaded portion. If it's not a solution, it won't be in the shaded portion. So let's look and see. Let's go ahead and label these. That would probably help me best if I labeled them. So positive 2, 1, 2, -3. So that one is. I have 5, 19, so 5 and all the way up to 19. It does not. It would be somewhere over in here, which we don't have enough room, but it's not. I did the math, I promise. So then we have negative 6 12. So I've got negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And then if we go down to 12, it's going to be somewhere way down here. It also is not part of my shaded area. So my last one is 10, negative 6. So I've got 6, 7, 8, 9, 10. Negative 6 would be down here. So it is part of my shaded portion. Now at the bottom it says, notice which points lie in the shaded and which points do not lie in the shaded. Any ones that lie in the shaded, again, are part of our solution sets, and any ones that lie outside of the shaded portion is not part of our solution set. Not part of our solution set. That's a mouthful. Let's try some more. All right. The freshman class at JSU are raising money to host their annual Honors Music Festival. The students plan to sell pizza for $25 each and slices for $5 each. If they need at least $750, how many of each should they sell? Now, first thing we have learned, anytime that I have a passage, I always want to go through and pick out all the important information in those passages. So let's go ahead and maybe label or circle some information in those passages. It will help us at the end of the problem to make sure that we've understood what we needed to find out. So let's look at this information. So they're selling the whole pizza for $25 and the slices are $5 each. And then I need at least $750. So I need to create a system of equations, or I need to at least create my equation to see what I've got. I think I'm just going to make an equation. I won't need a system. So I know that the whole pizza costs $25, and I'm going to add my $5 per slice, and they need to be at least, meaning they have to be $750 equaling it or more. That's how we determine which inequality symbol. We need to talk through it. Sometimes maybe you'll have to talk through it in your mind, but if you talk it out, you'll know which one of them that you'll have to use. So now that I have figured out what my equation is, let's see if we can work some problems. So here we go. We've got our equation of 25 whole pizza plus $5 slice is greater than or equal to $750. Anytime that we're doing work, we know that we can't use anything else in Desmos or in our calculator except our X's and our Y's. So I want to go ahead and make sure that I notate that. Okay, so I want to first estimate about how many do you think of each that we're going to use? I'm going to make my estimation. You make your estimation and go ahead and write it down on your paper and just put I guess, blah, blah, blah. I'm going to put mine, and then when we finish graphing these and finding out what our solution set looks like, we're going to come back and see if our guess was right. So I'm going to guess that I need to have at least 11 whole pizzas and maybe 15 slices. That's going to be my guess that I'm just going to leave there, and we'll come back to those guesses. So you put your guess down and kind of make a game of it with you and your table partner, see who gets the best guess. So let's go ahead and look. Now work your inequality plus graph and see if your guess is part of it. What I'm going to do is I'm going to plug this into my Desmos. I'm going to see what my Desmos can show me. So like we said, we can't put anything but X and Y, so I'm going to plug that in. So I've got 25X plus my 5Y, and that has to not equal, but my greater than or equal to symbol is down at the bottom above my pi symbol, and 750. Now, Ms. Killen, I don't see anything. I don't see any dotted lines. I don't see any shading. That's okay. We're going to zoom out, zoom out, zoom out. There we go. Everything that is under that red shading is part of our solution set. Any number out there that's in that shaded part is part of the solution. What exactly are we looking for? I want to know if first my guess is correct. Now, I said that my guess was what? Let's go back and see what our guesses were. My guess is 11 whole and 15 slices. That would mean 11, 15. So let's go back and see if my guess would be there. So what I'm going to do in my number 2 line on my Desmos, I am going to put 11, 15, and I'm going to label it. It shows me on Desmos that my guess was not right. Let's check another guess. Let's say that our guess was 9 whole and 2 slices. So let's plug that in. So I'm going to put 9, 2, and I'm going to label. That one's not either. Okay, let's see if maybe, just maybe, 30 whole pizzas and 27 slices. Oh, that's in the shaded portion. So if they sold 30 whole pizzas and 27 slices, they could get the money they need plus have a little extra. So that would be good. So you want to make sure that when you're looking at possible answers for these questions, you're going to see if it is going to be inside that shaded or if it's on the outside of that shaded, because all of my possible answers that will make that inequality true is going to be in that shaded portion. Good job. I really like those guesses. Okay, so let's look at the next one. It says, let's do some practice. We need to learn the calculator and Desmos working features. All right. So everybody pull up your calculator. We're going to see how we put in our dotted lines, which is our less than or equal, or less than or greater than symbols. We're going to see how we put in those solid lines, which is less than or equal to, greater than or equal to, and where we find those specific inequality symbols on my calculator. So let's go ahead and look at our calculator. Now, if you'll just work with me, and I just want to show you how these features work. So the first thing I'm going to do is go to my y equals function. I'm going to take my left arrow and scroll left and press enter. Now, when I use my greater than symbols, greater than or equal to, I scroll down. And I'm going to scroll to where it shows the shading going up. That is all of my greater than. Now, if I used my less than symbols, less than or equal to, we said that we shaded down. So I would scroll until I saw my shading is going down. This is how we plug it into our calculator. Depending on what our inequalities are, depends on how our shading would be at this point. So I'm just going to put in this one for now. Then I'm going to scroll back over, and I'm just going to put in something simple, 3x minus 14. And let's graph that and see. There's my table. Let's graph it. There's your graph. All of my possible solutions would be shaded in blue. All right, Ms. Killen, what about that other that you showed us? Okay, so let's say that my inequality symbol was greater than, where I'm shading up. So I scroll down and press enter. I'm going to go back over and graph it. Now I have an even larger portion on my calculator screen where all my possible solutions could be. So depending on which inequality symbol I plug in depends on where my shading is going to be on these calculators. Okay, so let's go back and look at Desmos. Now, Desmos is going to have the button there on its terminal or its front screen to put those inequality symbols in. So let's go ahead and try those real fast. So pull up your Desmos. when I pull up my keyboard, I see less than or equal to, greater than or equal to. So let's do y is greater than 4x plus 3. Now in Desmos, I notice my dotted line. It has that feature. What if I put in y is less than or equal to 2x plus 3? Notice I have a solid line for that. Remember, if I have a line underneath that inequality symbol, it's solid. If there's no line, it's dotted. So notice where my shading is. Now, if these were my two inequalities and I wanted to know a possible answer that would make both of these inequalities true, you're probably asking, Ms. Killen, where would I look for those answers? Good question. Right here, where they are both overlapping. In that purple area is where all of my answers would be to make both of those inequalities true, in that purple area. So we've learned how to plug in greater than, equal to, less than, equal to, or all those in our calculator. Now we've also seen how to look at them with our Desmos. So let's take these two tools and do some problems. All right. It says, let's graph on both of these about the freshman festival. Okay, so let's review some of that freshman. So I had 25x plus 5y is less than or equal to 750. So let's go and first plug it in our calculator. So I'm going to go to y equals. It is a greater than or equal to. So I'm going to scroll over, press enter. And I'm going to go down. And since it's greater than or equal to, it is going to be graphed up. So I'm going to press enter. Then I'm going to scroll over and put in the inequality. Now, in my calculator, I cannot put it in standard form, so I must change that into y equals mx plus b. So when I do that, I get 150 minus 5x. We've already learned that skill, so I am taking account that you know how to put that into y equals mx plus b form, and I'm going to graph it. Now, we're waiting and we're waiting and we're waiting, and Ms. Killen, I do not see anything on my graph on this equation or this inequalities that I put in. So what we're going to do is we're going to zoom. Everybody look at your top row, and the middle button says zoom. I want to zoom out and see if that will work. There it is. The more I zoom out, the more portion of that inequality is shown. So if I graph something on my calculator and I can't see it, I can always either zoom out to see the bigger numbers, or maybe they're tiny small numbers. I can always zoom in to see those smaller numbers. Just because it's the way it's shown when you start does not mean you have to leave it there. You can zoom in and out. All right, so now let's go and try Desmos for that same problem. So let's pull up Desmos and let's put this in. I've got 25x plus 5y is greater than or equal to 750. Same thing here. Since we've got a larger number, I'm going to have to zoom out. And there we go. All possible answers in that red shaded portion. So I have seen how to plug in these inequalities on my Desmos. I've shown us how to put these inequalities in our calculator. Now, let's see if we can use it to answer a problem. Let's look at some mastery. So it's time for you to master. First, I want us to sketch of the solutions of this inequality. Well, for me to sketch this, I need to go ahead and plug it into y equals mx plus b form. So that means I'm going to get my y by itself. So I'm going to do some calculations over here. So if I've got 6x plus 3y is greater than negative 12, getting y by itself, I am going to subtract my 6x on both sides. So then I would have 3y is greater than negative 6x minus 12. Still need to get that y by itself by dividing by 3 in all of my terms. So y is greater than negative 2x minus 4. Now that I have it in my slope-intercept form, I can go ahead and graph this. So I know that this is going to cross my y-axis at negative 4. So let's do negative 2, negative 4. It's going to right here. For me to go to my next points, I'm going to have to use my slope. It's negative, so I'm going to go down and then over. I'm going to go down 2 over 1. Making sure I have all the numbers I can possibly need on my graph. Make sure that you number your graph correctly. I have been known to do that. All right, so let's see. I've got, at negative 4, I'm going to go down 2 and over 1. Down 2 over 1, down 2 over 1, down 2 over 1. Now let's go the other way. Up 2 over 1, up 2 over 1, up 2 over 1. And so this, if Miss Killen could draw straight, would be my graph. That didn't hit the line, but that's okay. All right, so now I need to know which side I'm shading to. Am I going up or down? Well, it says that I have y is bigger. So that means I am going to shade up. This is where all my possible answers could be, is from here on my line up. Now here's my question. Should my line have been solid or dotted? You're right, it should have been dotted. So let's go ahead and make that look dotted. So I'm going to, you can use your pencil to make the dotted line, just erase some portions, or you can make a dotted line however you need to do. Sometimes it's easier for one to do it one way and someone else to do it the other way. All right, so now I have a dotted or slashed line. Now, the bottom question says, would negative 3, 1 be a solution? So let's go ahead and look at negative 3, 1. I'm going to go ahead and label it in red. So I go to negative 3 and go up to 1. Negative 3, 1 is going to be about right there. That's why I put it in red. It is not on the line, or it is not in the shaded portion. So I would say no. No, it would not. Make sure that your graph looks something similar to mine. Make sure that you have that dotted line, not a solid line. Make sure that your shading is up. And what you and your partners can do is guess some more answers. Is this part of the solution set? Is this not part of the solution set? And see what you get. Good job. I don't want to forget what our symbols mean, what those symbols meant when we had the different inequality symbols, what that equal sign, what that inequality symbol meant, what that equivalent symbol meant. I want us to make sure that we're not forgetting those. I want to know how to put different inequality symbols in my calculator. Remember, we're going where it has the y, and we're going to scroll to the left and change where the shading is, up or down. I want to be able to determine if an ordered pair is included with an inequality solution set. I've got to know where it lies on the grid to know if it's in my shaded portion. I'm so glad you came to learn here with us at MPB. I had such a good time. My name is Miss Killen, and have a good day.